Hello, I am Brent Edstrom, author of sound and music projects for Eurorack and Beyond. And in this video, we'll take a look at a solderless breadboard like this one. Breadboards are an essential part of electronics, and I like to think about it a little bit like manuscript paper is for musicians. We have a blank slate and can write notes and create compositions. And similarly, this is a blank slate that we can populate with components to create and test and perfect circuits that we might want to use, for example, to create a music synthesizer or a sequencer or something like that. Let's get our bearings with the solderless breadboard. First, we have a rail on the top, two of them actually. One is blue and one is red. And on this particular one, the blue is noted as negative and positive for the red. That's not entirely standardized, but I usually use that format because that's what we see typically with batteries, that red is positive and black is negative. And you'll see on the bottom another pair, blue and red. And the idea there is that's typically used for power. So in our case, we'll be applying 3.3 volts on that rail and using that to power a few of the devices that we're going to explore today. In the middle of the board, we have columns, and these columns are connected vertically. So where the rails are horizontal, the columns are vertical. And really important to remember that those columns are broken in the middle. So there's no connection between this column and the lower column. And that's really important when you're using devices like the teensy microcontroller or really any integrated circuit that has pairs of pins. You want those to straddle that middle part of the board so that you don't create a short and wreck your device. So once again, make sure that devices like ICUs and microcontrollers will straddle the middle part of the solderless breadboard to avoid a short. For the project today, I'm powering this with the teensy microcontroller itself and applying USB from a computer. And the teensy has an onboard 3.3 volt regulator. And so I've connected that pin to the top red rail. On the bottom left corner, we have a ground provided by the teensy, and so I'm using that for this blue rail. And that brings up something I want to talk about, which is purchasing a multimeter, a digital multimeter. These are not unduly expensive, and you'll find that this is really an essential tool for electronics experimentation. I use one almost every day when I'm doing electronics work. And this will provide a good opportunity to demonstrate one of the capabilities of the device, and that is continuity testing. So I'll turn the device on and go to this mode, press the function key, and this is something called a continuity tester. And the idea here, if I were to take the red alligator clip and then the black common clip and touch those, you'll hear that it emits a tone when there is a short. And so for purposes of testing our breadboard, let's get a feel for how those connections are made. I will start by connecting to any point on this ground rail. And so I have that connected to the black alligator clip. Let's use yellow for the red. And if I were to place that on the rail, you hear a tone. So that really tells us that signal, if you will, or in this case the ground, will be available horizontally. Let's check in the middle part of the board. And so if I were to test adjacent columns, you'll notice that nothing is heard. On the other hand, if I were to place it in the same column at any point, so that tells us that those points are connected. Let's create a first circuit, and we'll start with a simple light emitting diode. Light emitting diodes typically have a longer lead and a shorter lead, and the longer one is the anode, the positive side, and the shorter one, the cathode. And I'll just pick an arbitrary spot on the board to connect that. One thing I do want to highlight is how I'm placing it, this might be counterintuitive, between columns. And the idea is that if I were to apply power and have the device oriented this way, the power would just bypass the device because the voltage or the current will just follow the path of least resistance and just simply bypass that component. So get in the habit of connecting the components from column to column in this way. Let's apply 3.3 volts. And again, that's coming from the microcontroller to one side of the LED. Let's connect the other side to ground. And voila, we've got a first circuit. So we've got 3.3 volts powering the device. It goes through the light emitting diode, and then that circuit is completed with this connection to ground. One of the things to keep in mind with LEDs is that they like to gobble up current, and so much so that they'll often burn out if you provide too much juice, if you will, to the LED. And so typically it's important to add a current limiting resistor to the circuit. There are some great calculators online that you can use to calculate a resistance value, but the basic idea is to take your source voltage, 3.3 volts in this case, subtract from that the forward voltage. So that's the amount of voltage that it takes for current to flow through the component. And for example, 2 volts is a common amount for an LED. And so now if you're kind of doing the math in your head, we would have 3.3 minus 2 is 1.3. And then we divide that by the amount of current. And in the case of this LED, it's 20 milliamps, or how we'd have to use it in the circuit would be 0.02 amps. And so that comes from a basic electronic equation that some people describe as a very important rule. Voltage is equal to current divided by resistance. And of course, using a little algebraic manipulation, you can also use that to determine a resistance value and say that resistance is equal to the voltage divided by current. Many times when you buy an LED, they may even come with resistors, and certainly there will be some documentation on how to pick a resistor value. And it's not really crucial, but just wanted to say a few words about that. So let's add a resistor. And before we do, I'd like to demonstrate another mode of the multimeter, and that is the ohm meter. So if we go to the first function here, it will provide the amount of ohms in the circuit. And all we need to do is connect one lead on the alligator clip to one side of the resistor, doesn't matter which, and the other side to the other. And now you'll notice that the ohm meter is showing just shy of 100 ohms, which will be ample for this application. So let's apply that to the circuit. I'm connecting one lead to, if you will, the input side. The other side will get connected to our voltage, 3.3 volts. And here it doesn't matter if it's top or bottom. That current's going to flow on either side. And then we will complete the circuit with a connection to ground. And there you can see it's just slightly more dim, and the resistor is doing its job. Let's talk about another common component, and that is a potentiometer. This particular potentiometer is also called a trim pot. It's small, and these are used in a variety of ways in electronics, but they're a nice choice for breadboarding. Of course, with final projects, you'd want a nice big potentiometer with a knob, but these are nice to use for breadboarding. And the idea here is that there are two modes of operation of a potentiometer. If we were to use one of the outer legs and the middle leg, it would function as a variable resistor. Or if we were to apply power to one of the outer legs, ground to the other typically, and then the middle one provides a voltage divider. And that's how I will wire this one up today. And the idea is that I like to be able to dim that LED. So let me add that to the circuit. You'll see here those legs, 3 of them. I'll put those right here. Let's connect the 3.3 volts to one side. The other side will connect to ground. And then the output, the middle pin or lead, we will use to power the LED. So that's going to one leg of the resistor. And then finally, to complete the circuit, we connect the cathode to ground. And now you can see that that LED is dimmable, which is pretty cool. And I do want to stress, when you're using potentiometers like this in conjunction with a microcontroller, on the Teensies, it's really important that you're using the 3.3 volts and not the higher 5 volts because applying that output to one of the pins on your microcontroller will damage it. And so that's why I want to really stress, when you're doing this kind of work, we could take this output and put it to one of the analog inputs here on the Teensy. That will be safe with this lower voltage. However, if we were to be using this 5 volt USB power to power the rail, then that would damage the device. Okay, so one other exploration will involve another common device, and that is a push button. This is a small push button called a tactile push button that would be typically used on a PCB. These are great for breadboarding. Many of them fit very nicely into a breadboard. And let's take a close-up. And before we explore this, let's use the continuity tester of the multimeter to get a feel for how the push button works. So you'll notice that I have 2 of the leads that are on the same side, and they're not making connection until I actually press the button, and that completes the circuit. On the other hand, if I were to connect on the same side, top and bottom, you can hear that does create a short. So very simply, all we do is apply a voltage to one side and then take that output, if you will, on the other side and power our circuit, and then complete that circuit with its ground connection. So when I press the button, hopefully this will light up, and there it is. So those are just a few of the types of things that you can do with a breadboard. And if you're new to electronics, I would encourage you by saying that even though we explored just a few components, push button, resistor, and LED, those are the primary tools that we will use for many of the fun electronic music projects in the book. And so just like I described in the book, you could do a lot of cool music with 3 chords. There's been some great music written with 3 chords. Well, you can do quite a bit using these basic components. And so I encourage you to get a hold of a breadboard and a multimeter. You just need some hookup wire, some inexpensive components, and you can start your journey. And so I hope you found this video to be useful. Thank you.